a term used mainly in literary translation and advertising that refers to the process of adapting a text from one language to another by discerning the emotional responses of the audience in the source language and by working to elicit the same response in the target language audience is known as transcreation. Now, please explain what transcreation really means and also what this statement in terms of transcreation means.
Transcreation is a term used in literary translation and advertising. It involves adapting a text from one language to another, not just by translating the words, but by capturing and recreating the emotional impact and intended response of the original text in the new language. It's more about maintaining the same effect and emotional tone rather than just a direct translation. For example, if a slogan works well in English but needs to resonate equally in Spanish, transcreation ensures that the Spanish version evokes the same feelings and response as the original.
So can you briefly elaborate what this sentence really means in simpler terms, in simple terms?
Sure. Transcreation means taking something written in one language and adapting it so it has the same emotional effect in another language. It's not just about translating the words, but making sure the new version has the same impact and feels right to the new audience.
Now, please explain what is formal and dynamic equivalence. Formal and dynamic equivalence. Please explain these two terms in what do you say that in brief? Yeah, briefly explain both of these terms introduced by Eugene Nida.
Formal equivalence focuses on translating words and sentence structure as closely as possible to the original text. It tries to keep the form and content of the source text intact. Dynamic equivalence, on the other hand, aims to convey the meaning and impact of the original text in a way that feels natural to the target audience, even if it means changing the wording or structure. Eugene Nida introduced these concepts to balance accuracy and readability in translations.
So, what does formal equivalence and dynamic equivalence mean? I mean, explain the mechanism of its working. What does this explain?
Formal equivalence works by sticking closely to the source text's structure and wording, ensuring that every detail matches as much as possible. It's like translating each word and sentence almost exactly, preserving the original form and grammar. This can be useful for technical or legal documents where precision is crucial. Dynamic equivalence, however, focuses on conveying the same meaning and emotional impact as the original text, even if the wording or structure changes. It adapts the content to make sense and resonate with the target audience. This approach is often used in literature or marketing, where the goal is to make the message effective and engaging in the new language, rather than just matching the original text word for word.
And what does transliteration mean? Transliteration. Transliteration. What does this term mean?
Transliteration is the process of converting words or text from one writing system into another. It focuses on representing the sounds of the original language as closely as possible in the target language's script, rather than translating the meaning. For example, the Hindi word namaste is transliterated into namaste in the Latin alphabet.
All right, moving on to the next question. Which of the following is not true? The first, Babbage's first attempt at a mechanical computing device, the difference engine, was a machine designed to tabulate logarithms and trigonometric functions. Next, Gödel showed that there were limits to what could be proved within a formal system by his incompleteness theorem. Next, Ada Lovelace, during her work with Babbage, became the designer of the first computer algorithm, which had the ability to compute Bernoulli numbers. Next, Babbage created the analytical engine, which started work in 1810. The one that is not correct.
The statement that is not true is Babbage created the analytical engine, which started work in 1810. Babbage's analytical engine was actually designed in the 1830s, not 1810. The other statements are accurate.
Please explain what the statement, Babbage's first attempt at a mechanical computing device, the difference engine, was a machine to tabulate logarithms and trigonometric functions. Please explain what logarithms and trigonometric functions really mean. What do they, in simpler terms, what do they calculate? And what was the difference engine, and how does this statement what this statement really stands for?
Logarithms are a way to simplify multiplication and division into addition and subtraction, making complex calculations easier. Trigonometric functions, like sine and cosine, help in calculating angles and distances in triangles. The difference engine was an early mechanical computer designed by Charles Babbage to automatically calculate and print mathematical tables, including logarithms and trigonometric functions. The statement means that the difference engine was designed to handle these kinds of calculations automatically, which was a significant advancement at the time.
Now, the third statement, Ada Lovelace, during her work with Babbage, became the designer of the first computer algorithm which had the ability to compute the Bernoulli numbers. Now, I want you to elaborate briefly and simply what Bernoulli numbers really are, and what was the contribution of Ada Lovelace during her work with Babbage.
Bernoulli numbers are a sequence of rational numbers that appear in various mathematical formulas, particularly in number theory and calculus. They help in calculations related to sums of powers of integers. Ada Lovelace worked with Charles Babbage on his analytical engine, an early mechanical computer. She is credited with designing the first algorithm intended for this machine, which was an algorithm to compute Bernoulli numbers. This work made her one of the first people to recognize the potential of computers beyond simple calculations, laying the groundwork for modern computing.
Could you please briefly explain what you just said?
Bernoulli numbers are special numbers used in math for solving certain problems. Ada Lovelace created the first computer program to calculate these numbers for Charles Babbage's early computer, showing how computers could handle complex tasks.
Do you really feel like I understand everything that you explain?
I try to explain things as clearly as possible, but if anything's still unclear, just let me know. I'm here to help with any part you want to revisit or clarify.
In which year did Babbage created the analytical engine? Was it 1837?
Yes, Babbage conceived the analytical engine in 1837.
Moving on to the next question. Which of the following is true for a compiler? Errors are displayed for every instruction, making debugging easy. Not true. Programming languages like C use it. Takes signal instruction as input instead of the entire program. Does not generate an intermediate object code. So the one that is true for a compiler is that programming languages like C use it. Now I want you to explain why the other statements that I just mentioned and which are also mentioned in the text relating to the question we are discussing, they are also mentioned over there. So why are these statements not related to the compiler?
For the first statement, errors are displayed for every instruction, making debugging easy. This isn't true for compilers because they generally check the entire program for errors at once, rather than displaying errors one instruction at a time. This means you might not see detailed errors for every single line as you would in an interpreter or debugging tool. The second statement, takes single instruction as input instead of the entire program, is not accurate for a compiler because a compiler processes the entire source code of a program at once, not just individual instructions. The third statement, does not generate an intermediate object code, is incorrect because compilers typically generate intermediate object code as part of the process before producing the final executable code. In contrast, the true statement, programming languages like C use it, is correct because languages such as C are compiled languages. They use compilers to translate the source code into machine code.
Can you demonstrate or exemplify these statements, the incorrect statements, like why are they incorrect, and with examples like in application it would fail if we apply this statement, and with an example.
Certainly. Let's look at why each incorrect statement doesn't apply to compilers with examples. 1. Errors are displayed for every instruction, making debugging easy. Why it's incorrect. Compilers don't display errors for each individual instruction, as they analyze the entire code in one go. They compile the whole program and show errors for the entire code at once, often summarizing them in a list. Example, suppose you have a C program with several syntax errors. If you compile it, the compiler will list errors across multiple lines and possibly different files, but it won't stop and show errors line by line. For instance, if you miss a semicolon in several places, the compiler might report the errors in a summary form rather than interactively as you type. 2. Take single instruction as input instead of the entire program. Why it's incorrect. A compiler processes the entire program's source code all at once, not just individual instructions. Example, imagine writing a complex C program with multiple functions and classes. You can't compile just one instruction at a time. The compiler needs to see the whole program to correctly understand context and generate machine code. For example, if you declare a variable in one function and use it in another, the compiler needs to see the entire program to resolve references and errors. 3. Does not generate an intermediate object code. Why it's incorrect. Most compilers generate intermediate object code as part of the compilation process. This intermediate code is then linked to create the final executable. Example, when you compile a C program, the compiler first generates an object file, .obj or .o, that contains machine code but isn't yet executable. This object file is then linked to create the final executable. If a compiler didn't generate intermediate object code, it would have to produce the final executable directly from source code, which is less efficient and would complicate the process of linking different code modules.
Oh, you are so intelligent.
Thank you. I'm glad I could help. If you have any more questions or need further clarification on anything, just let me know.
तेरे सिटी दे रेडियो ते गबरू दा ना चलदा. All right, let's move on to the next question. So the next question talks about in-text encoding initiative. An anchor is an arbitrary point in a document. Now, please explain what this statement really talks about, what it is. Give me examples, demonstrating that, okay, this is the thing that is being talked about by this statement.
Anchor specific location or links can be direct. For example, that's an later create a that's directly the methodology, making it easier for you to find information quickly.
The problem is that I could not hear a word that you said. So please repeat the same information one more time so that because I did not hear anything.
In-text encoding involves adding references or markers within a document. An anchor is a specific point in the text where you can link or direct information. For example, if you have a long document and you add a link that jumps to a specific section, that link is anchored to a point in the text. It helps readers quickly navigate to relevant sections.
Can you simplify your explanation and then accompany it with the complex explanation for better understanding, and also exemplify what this really means?
Simple explanation. In-text encoding means putting markers or links in a document to help you find specific parts. An anchor is just a spot in the document where you can jump to or link from. For example, if you have a long report and you want to go directly to the conclusion section, you can create a link that takes you right there. Complex explanation. In-text encoding is a method used in digital documents to make specific parts easily accessible. Anchors are these reference points that you set within a document. They allow for internal linking, meaning you can jump from one part of the document to another without scrolling. This is useful for organizing large documents, making navigation efficient, and improving user experience. For instance, in a web-based report, you might use anchors to link directly to sections like Introduction, Methodology, or Results. This way, readers can click on a link and be taken straight to that section, enhancing the document's usability.
All right, move on to the next question. Next question is a speech disorder characterized by fluency disrupted by involuntary repetitions and prolongations of sounds, syllable words, or phrases, as well as involuntary hesitations, is called what? So, a speech disorder characterized by fluency disrupted by the involuntary repetitions and prolongations of sounds or syllable words or phrases. It's basically stuttering. Stuttering as in be, be.
Yes, you're right. The speech disorder described is known as stuttering. It involves interruptions in the flow of speech, including repetitions of sounds or syllables, prolongations, and hesitations.
So, could you please briefly give me a paragraph about a couple of mischievous people who create nuisance? Not people, but a mischievous a group of friends who are very close to each other, but their major work is mischief. Now, imagine one of the students has this problem of stuttering, right? So, imagine like these mischievous people are about to create some nuisance. So anything like blasting a bomb in their classroom, because it's the celebration of Diwali, like we celebrate in India. So imagine what they how they will plan everything out, right? So for example, let's say that they want to blast a bomb in the school electricity, the classroom electric board, so it has switches for fans and lights and everything. So imagine a scenario where they're planning a hypothetical scenario where they're planning to do this blast thing on the celebration of Diwali. So one of the friends, who is named Vivek, is actually he has this problem of stuttering. Now go ahead and plan this out, plan this out. It's a conversation going to be in Hindi, so all of them are talking in Hindi. So there are three friends, right? So explain this whole scenario of who says what to whom, right? There are three friends: Roshan, Shubham, and Vivek is the one is who has this problem of stuttering. And okay, they are planning, right? So Vivek has the main task of planting the bomb and blasting it. Now create this conversational dialogue between these three people, these three students.
और क्लासरूम में दिवाली के दिन कुछ इनके बेट हैं। आज उन क्लासरूम का इलेक्ट्रिक बोर्ड उड़ाना है। दिवाली के दिन सब लोगों का ध्यान छोड़ो, हम बड़ी धमाका कर। शुभम ने दिया, हाँ और विवेक, तू तो बम लगाने का काम करेगा ना? जो स्टटर करता है, देर से बोला, मैं भी बम लगाऊंगा। लाइट्स फॉर फैंस के स्विच क्लास। उसकी बात रही थी, लेकिन रोशन ने उसे मत दी। हाँ विवेक, तू सही कर सकता है। हम सब मिलकर इस परफेक्टली एग्जीक्यूट करेंगे। शुभम ने विवेक सबसे पहले तो बम को इलेक्ट्रिक बोर्ड के साथ लगाना, फिर हम चुप कर देंगे कि सब लोग शॉक हो जाते हैं। विवेक ने कुछ हिम्मत दिखाई और कहा, ओके, मैं काम शुरू करता हूँ। रोशन और शुभम विवेक को देखते हुए प्लान को फाइनलाइज करते हैं और आज की दूसरी एक्टिविटीज को भी अरेंज करते हैं ताकि कभी उनके प्लान को सस्पेक्ट न कर सके।
So I wanna know, like, specifically how Vivek speaks in this whole conversation.
विवेक, जो स्टटरिंग का शिकार है, अपनी बात को थोड़ा रुक करके बोलता है। जब रोशन और शुभम प्लान डिस्कस करते हैं, विवेक का डायलॉग कुछ इस तरह होता है। विवेक, तू बम लगाने का काम करेगा ना? मैं बम लगाऊंगा। L लाइट्स और फैंस के स्विच के साथ। हाँ विवेक, तू सीख सकता है। ओह ओके, मैं शुरू करता हूँ। इस कॉन्वर्सेशन में विवेक अपने वर्ड्स को थोड़ा स्लो और हेसिटेट करके बोलता है, लेकिन रोशन और शुभम उसकी मदद करते हैं और उसको कॉन्फिडेंस देते हैं।
Okay, let's move on to the next question. The next question is about PC Kimmo. So there are two assertions. Assertions. The first is that the two functional components of PC Kimmo are the generator and the recognizer. Two functional components of PC Kimmo are generator and recognizer. Second, the generator in PC Kimmo does not use the lexicon. However, it accepts the lexical form as input, applies the phonological roots, and returns the surface form. So basically, both of these statements are true, but what I want to know is that so the first assertion is that the two functional components of PC Kimmo, that is the generator and the recognizer, what do they really function as, or what do they stand for? Give me a real life example which demonstrates what they function as. The generator and the recognizer, these are the two functional components of the PC Kimmo. So I want to know, what do they really do? The second assertion is that the generator of the PC Kimmo does not use the lexicon. It does not use the lexicon, but it accepts lexical form as input. Generator does not use the lexicon, but it accepts the lexical form as input, the generator, and then it applies the phonological rules on those lexical forms, and then returns the corresponding surface form. So I want to know what this assertion really means with a real life example, with a real life demonstration. So I want everything to be explained and exemplified at the same time for better retention.
Let's this down. PC Chemo is a model used in linguistics to understand how words and sentences are formed and recognized. It involves two main components, the generator and the recognizer. The component creates or generates surface forms of words or sentences from their underlying lexical forms. However, it doesn't use the lexicon directly. Instead, it takes lexical forms, like abstract representations of words, as input, applies specific rules, called homological rules, and produces the surface forms, the actual spoken or written words. Example, imagine a language where the word walk has different forms based on tense, like walked, for past tense. The generator doesn't use a dictionary, but takes the base form walk and applies rules to produce walked when needed. 2. Recognizer. This component identifies or recognizes words and sentences by breaking them down into their underlying forms. It works with the surface forms to figure out the underlying lexical forms. Example, if you hear or see the word walked, the recognizer would analyze it to determine its base form walk. So in a real-life situation, imagine a software system that processes different forms of verbs. If the input is walked, the recognizer will analyze this and determine that the base form is walk. The generator, on the other hand, might take the base form walk and apply rules to generate the form walking needed. The second assertion is that the generator does not use the lexicon directly. It works with forms given to it and applies rules to convert them into surface forms. This means it's not looking up words in a dictionary, but rather applying a set of rules to create forms based on the input it receives. Example, if walk is the input, the generator might not check a dictionary, but will apply rules to generate walked or walking based on grammatical rules. So in summary, generator transforms lexical forms into surface forms using rules. Recognizer identifies the underlying forms from the surface forms. This way, PC Chemo helps in understanding and processing language forms and their transformations.
Okay, so now tell me who developed this model of PC Kimmo? Who were the major contributors to this tool PC Kimmo? When was it developed? And in which work was it proposed? When was it developed? Like the year in which it was developed? Who were the major proponents who are associated with PC Kimmo? Is there a full form or an abbreviation of PC Kimmo? Tell me about those. Like,
The model of PC Chemo was developed by David Stam, major contributor with PC Chemo. The model was developed during late
करने दो इसको पाधा नीसा. जब ये कर लेगा ना, इसके बाद मैं जाऊंगा बैक. I'll read it out and then I'll. Woo! What the fuck? Bro, give me the text that you spoke about PC Kimmo. Generator, recognizer, do I wanna know if this feeling hurts so bad? Okay, so this is the information that I'm getting. The model of PCKMO was developed by David Stampy. David Stampy, the major contributors associated with PCKMO are Stampy himself. The model was developed during the late 1960s and early 1970s. It was part of the work on the theory of phonological change published in 1969. PCKMO is an abbreviation and it stands for Phonological Computation. PC Kimmo, not PC Chemo. Kimmo. It's Kimmo. It's not Shemo. What can you tell me about it? Generator and recognizer. Cool. So PCKimo is a computational tool used for morphological analysis named after its developers Kimmo Koskeniemi. Kimmo Koskeniemi and Lori Kartunen. Kimmo, PC Kimmo. देख लो तू आके देख ले कि मैंने रातें कितनी सारी तेरी यादों में गुजारी सोनिए सोनिए तू आके देख ले. So as you can see the names, what are the names? Koskeniemi and Laura. It's all reversed. So you get the idea, right? Now, Laurie Kartunen. Now it implements the two-level morphology model developed by Koskeniemi in 1983, which is widely used in computational linguistics for processing the morphology of natural languages. What does PCKMO do? PCKMO is designed to analyze and generate word forms in languages with complex morphology. It consists of two main components. The first is generator. It creates surface forms, for example, words from lexical forms, for example, roots and the affixes. So it creates surface forms from the lexical forms. And the second is recognizer or parser. It recognizes and analyzes surface forms, breaking them down into their component morphemes. How does it work? The key idea behind PCKMO is the two-level model of morphology. The first lexical level represents the underlying or abstract form of a word, for example, a root and its morphemes. Second, surface level, it represents the actual word form as it appears in text or speech with the phonological rules applied. So, lexical level uh, represents the underlying or abstract form of a word, for example, a root and its morphemes, and surface level as it has the actual word form as it appears in a text or speech. Now, the system uses rules to map between these two levels, so it can account for the changes that happen when morphemes are combined. For example, in English the plural morpheme s might appear as in es in words like boxes. PCKMO can model these kinds of changes systematically. Real life example, suppose you are analyzing the word boxes, lexical form box, that is root, plus plural, surface form boxes. Now PCKMO would apply phonological rules to generate the surface form from the lexical form or analyze the surface form to retrieve the underlying morphemes. History and development developed by Kimmo Koskeniemi with the contributions of Laurie Cartoonan and others. Here, the two-level morphology model was proposed in 1983. Koskeniemi's work on two-level morphology has had a significant impact on computational linguistics, particularly in the area of morphological analysis. Now, this model is particularly useful for languages with complex morphology such as Finnish or Turkish, where words are often formed through the addition of multiple affixes to a root word. Now, Finnish and Turkish are both agglutinative languages, like Tamil. Tamil is also an agglutinative language, as we have previously even seen the examples, the real life examples in Tamil. They are pretty much complex, yeah. Kadu, uh, very difficult. I don't recall, but it's like too many roots coming together with altered forms. A two would add up as just two or double tu. No, so a two would compress and then add up, and various other forms would compress in the same way and add up to make one single word. So that's how the agglutinative, was it agglutinative or inflectional? I'm not really sure, because I think it was inflectional. Tamil, Finnish, Turkish are inflectional languages, not agglutinative. So मिलते हैं. And you did hear the story about you know bum फोड़ने वाला. So stutterers basically speak like अबे बे अबे तेरी माँ की. I wanna play this one now. It's from the movie Dhamal or Golmaal. 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 तेरी माँ की. हाँ, माँ की
क्या बोल
शादी
रही है
होगी.
डब्बू? माँ की
हाँ माँ की शादी लक्ष्मण. गोपाल, इसमें माँ की खुद की खुशी है.
अरे खुशी नहीं, खुदकुशी. क्यों भा?
नारियल के ऊपर वाले कड़क हिस्से की तरह मत सोचो, अंदर की तरह नरम दिल से सोचो. ये उन दोनों की इनकम्प्लीट लव स्टोरी है, जिसकी हैप्पी एंडिंग अब तुम दोनों की परमिशन पे डिपेंड करता है.
कैसे हाँ बोल? वो भी अपने माँ की.
अभी तेरी माँ की
ये?
खुशी देख लक्ष्मण, जिससे वो प्यार करती है, उनकी खुशी देखो, उनके मासूम बच्चों की खुशी देखो. उनको भी माँ का प्यार मिलेगा ना. और तुम दोनों से अच्छा कौन जान सकता है कि माँ का प्यार क्या होता है.
वो सब तो ठीक है डब्बू,
लेकिन क्या, तुमने तो कहा था कि अब टाइम आया है माँ के लिए कुछ करने का.
अच्छा, सपोज हम लोग मान भी जाते, लेकिन लोगों का क्या? लोग क्या कहेंगे भा? हंसेंगे हम पे, कहेंगे देखा जॉन बेटा निकले अपने माँ की.
कुछ तो लोग कहेंगे, लोगों का काम है कहना. तुम जमाने की फिक्र कर रहे हो. तुम्हारी माँ ने तुम दोनों को बड़ा करने में कितनी प्रॉब्लम्स फेस की, तब तुम्हारे जमाने ने तुम्हारी माँ की फिक्र की. तुम्हारी माँ ने पसीना बहा के घर चलाया, सैक्रिफाइसेस दी, तब तुम्हारे जमाने ने तुम्हारी माँ की फिक्र की. माँ का सपना इम्पोर्टेंट है या जमाने की हकीकत? माँ का प्यार इम्पोर्टेंट है या जमाने की नफरत?
छोटे छोटे मासूम बच्चों को उनकी माँ का प्यार मिलेगा.
हाँ, ये तो इतना छोटा है, बेचारा बोल भी नहीं पाता.
वाह, लेकिन जमाने की ऐसी की तैसी. माँ की शादी हो गई.
माँ की